Welcome to the Walton Pie. Today we're going to be talking about how we can use integrals to find volumes of solids. So the general idea of this is if we're trying to find an integral that represents the volume of an object, we are going to be using how we would normally compute a normal volume in order to compute the volume using an integral. So if we are able to slice our object, for example, into slices, those slices can act like prisms or cylinders. And since those have a very nice formula for volume, you just take the base and multiply it by the height, that's going to give us a nice form to be able to find integrals that can help us solve for the volume. So for example, let's say we have a three-dimensional object and we're just trying to figure out what the volume of that object is. So here's our object. If we were to slice it vertically, we're going to get a lot of very thin slices like this. So if we can figure out what the area of a slice is, so find a function that gives us the area of a slice, the volume of the object is going to be the area times dx inside an integral from a to b. Each of these pieces represent something similar to how we would find the volume in a regular object. So our a of x, that gives us an area, so that gives us like meters squared, for example. Dx is measuring like the thickness of a really thin slice, so that's another unit of length. So we have 2 units of length multiplied by another unit of length. That gives us, for example, meters cubed, so that's going to give us a volume. And then the a and b, that's just saying where does the object start and where does the object end. So we're integrating from the start of the object to the end of the object, time of the area of the slices times the thickness of each slice, which is the dx. So that's how that gives us a volume. So a of x represents the surface area, and that's how we're able to go about it. So let's do an example. Let's say we're trying to find the volume of a square pyramid with a base of side length 12 meters and a height of 8 meters. Let's try and figure out how we might set this up using an integral. So the first step is we have to figure out how we want to slice the pyramid. If we were to slice it vertically, our slices are going to be trapezoids. So it's doable to find the area of a trapezoid. It's 1/2 base 1 times base 2 times the height. That would be the area of a trapezoid, but that's a slightly complicated one. So if there's an easier slicing method, we're probably going to want to do that one instead. So if we were to instead slice it horizontally, each slice is going to be a square, which is a lot easier to define than a trapezoid. Doing it with the trapezoid wouldn't be wrong, it just would not be quite as easy as doing it with the square. So what we would need to do is we need to find the volume of a square pyramid with a base of side length 12 and height 8, and so we are going to need to figure out what's the area function of each slice. So we are going to need to have a variable, and so we are going to just let x represent the height from the base of the slice to the top. So we are going to have the bottom of our pyramid is going to be x equals 0, and the top is going to be x equals 8. All that's going to be left is a formula to find the cross-sectional area of each slice. So the slice is a square. That means we just need to figure out what the side length is, and then we can square it, and that'll give us the area of each slice. And the way we are going to approach this is using similar triangles. So the way that we're going to approach it using similar triangles is similar triangles have ratios of different sides are the same between similar triangles. And so if we can set up a system of similar triangles here, that's going to give us a way that we can find the ratios between the different sides that we would need. Now, even though the height of the pyramid is not directly connected to the side length through similar triangles, we can treat it that way as the length of the square is changing linearly, and there's a system of similar triangles that would get it to that point. So here's our triangle. So the height is 8 meters, the base is 12 meters, and we are trying to figure out the side length s. So if we were to draw this vertical line, we know x is the height, so x is the distance from the bottom to the top to the slice, and so that means that the distance from the slice to the top of the pyramid is going to be 8 minus x. So similar triangles say that we can have base over height is the same no matter what triangle we're looking at. So the base of our top triangle is s, and the height is 8 minus x, so s over 8 minus x is equal to the base of the big triangle over the height of the big triangle. So s over 8 minus x is equal to 12 over 8. So if we solve for s, that means s is going to be 3 halves times 8 minus x. So we have found our side length. What we then need to do is we need to figure out what's the area of a slice. So the area is just a side length squared since it's a square. So that means the area is going to be 3 halves of 8 minus x squared. So our volume is the integral from a to b, start of the object to the end of the object, of our area function times dx. So it's going to be the integral from 0 to 8 of 3 halves times 8 minus x all squared dx. Computing this, we are going to be able to pull out the 3 halves squared, so that's a 9/4. So we get 9/4 the integral from 0 to 8 of 8 minus x squared. We can do a u substitution, so this is 9/4 the integral from u equals 8 to u equals 0 of negative u squared. This is where we are saying that u is equal to 8 minus x, and this is how we would be able to write that. So this then becomes negative 9/4 of u cubed over 3 evaluated from 8 to 0. So that gives us negative 9/4 times 0 thirds minus 8 cubed thirds. So negative 9 over 4 times negative 512 over 3, which is equal to 384. That tells us that the volume of this pyramid is going to be 384 cubic meters. I hope this video was helpful. Please check out my next video where we will go through some more integrals with volumes. And please like and subscribe if you haven't already so I can continue to make these videos. Have a great day and good luck with the rest of your math.